All right, we're moving on to 5.4. It says, so far, we know that if it's a parallelogram, then it has certain characteristics. What about if we are trying to prove that something's a parallelogram based on the characteristics? So it says, try drawing quadrilateral with the following characteristics. Identify if the characteristics ensure that the figure must be a parallelogram. It might be easier to try to find a figure that is not a parallelogram. Circle ones that seem to show that the figure is a parallelogram, and X out the ones that are non-examples. So the first one says one pair of opposite sides being parallel. This could be a trap, so that's not it. The next one, two pairs of opposite sides being parallel. Well, I've already drawn one pair that's parallel, and if you draw any other two sides that are parallel, you see that it ends up being a parallelogram. That's called definition of parallelogram, is why it's going to be a parallelogram. One pair of opposite sides are parallel and the other pair are congruent. That could be just an isotrap, so that's not it. One pair of opposite sides are parallel and congruent. So if you get on those parallel sides and then just make any exact same length so that they're congruent, when you connect everything else, it turns out to be a parallelogram. So circle that one. One pair of opposite sides are parallel and congruent. The next one, diagonals bisect one another. I drew one diagonal, draw another diagonal that goes through that middle, and so that the one that's already drawn goes through the new one's middle. And when you do that and connect all the rest of the pieces, you end up getting a parallelogram. So that's one of them. If diagonals bisect one another, then it's going to be a parallelogram. If both opposite angles are congruent, let's check. I made an angle across from the 130, that's 130, and then across from the 50, that's a 50. And you can see it turns out to be a parallelogram. So yes, if both opposite angles are congruent, then it is going to be a parallelogram. The next one, all consecutive angles are supplementary. I already had a 60. I made a 120 and a 120. And once I did that, it ends up being a parallelogram. So yes, if all consecutive angles are supplementary, then it's going to be a parallelogram. One pair of opposite congruent angles, that does not work because that could be a kite. And then last one, both opposite sides are congruent. I said use straws, and if you grab two straws that are the same length and another two straws that are the same length and go opposite one another and try to make them congruent, you end up always getting a parallelogram. So what this tells you in the quick notes is that a quadrilateral must be a parallelogram if both opposite sides are parallel, if both opposite sides are congruent, if both opposite angles are congruent, if an angle is supplementary to both consecutive angles, if the diagonals bisect one another, or if one pair of opposite sides is both parallel and congruent. Now the word both is very important here. If you just say opposite sides are congruent is the reason, well, you could look at a isotrap and that has opposite sides that are congruent and it's not going to be a parallelogram. So you have to say both for a lot of these. Anytime that I underline the word both, it is necessary when you're justifying why something needs to be a parallelogram. Now this next one says, we know that if the lines are parallel, then SSIAs are sup, and if AIA, AEA, CAs are congruent, or that they're going to be congruent, the converse is also true. What this means is that you know that the SSIAs are supplementary or those other type of angles are congruent, then you know that the lines must be parallel. And that'd be the converse of either AIA theorem, AEA theorem, or CA theorem, or SSIA. So you use the converse when you're trying to prove the sides are parallel or the lines are parallel, and use the theorem when you know that they're parallel. We've always been using the theorem. We'd use the converse of the theorem when we want to prove things are parallel. So it says, what triangles must be congruent? Well, the left and the right must be congruent, and up and down by SAS, as we have the diagonals bisecting one another, and then you also know that you have the vertical angles theorem. What angles must be congruent? The greens and the blues by CPCTC. So on here it says, how does this ensure that they are parallel? Well, we found out that the alternate interior angles had to be congruent on here. And what I just told you is if the alternate interior angles are congruent, then those sides have to be parallel by the converse of the alternate interior angles theorem. If we saw that the SSIAs were supplementary, you could say that they had to be parallel by the converse of SSIA. If the corresponding angles were congruent, then you would say they had to be parallel by the converse of the corresponding angles theorem. Okay. Now, the next one says, determine if we have enough information to determine if the following are parallelogram is a parallelogram. If so, justify your answer. If not, what other figure could it be? On this one, we're going to ignore those first set of angles that are being congruent because it's not both opposite angles being congruent, but we do have both opposite sides being congruent. So that would be a parallelogram because both opposite sides are congruent. The next one, we're going to ignore the fact that those opposite sides are congruent because we don't have both opposite sides, but we do have both opposite angles. So this would be a parallelogram because both opposite angles are congruent. The next one is no. While we did have something about opposite sides being parallel and congruent, this is different sides. One pair are parallel and one are congruent, and this could be an isotrap. The next one, the 100 and the 80. The 100 and the 80 are SSIAs that are sup, which means top and bottom have to be parallel by the converse of SSIA postulate. They're also congruent, and if they're both parallel and congruent, it has to be a parallelogram because one pair of opposite sides are both parallel and congruent. The next one says the midpoint of both of them are going to be 2, 3. Is that going to be a parallelogram? Yes, because if they both have the same midpoint, then they must be bisecting one another. And if diagonals bisect one another, it's a parallelogram. And the last one says A and B add to be 180, B and C add to be 180, C and D add to be 180, and D and A add to be 180. And that would be yes, because the angle is supplementary to both consecutive angles. So those are your reasons. Now moving on to your homework. It says, what are the 6 ways that you can prove any quadrilateral is a parallelogram? You can draw or write them out. So one is if both opposite sides are parallel. That's just definition of parallelogram. Also, both opposite sides being congruent, both opposite angles being congruent, angle is supplementary to consecutive angles, one pair of opposite sides are both parallel and congruent, and the diagonals bisect one another. Any one of those ways would be enough to be able to prove that something that is a quadrilateral is a parallelogram. Why is the word both so important when justifying something is a parallelogram? For example, why do you have to say both opposite angles are congruent? What is a figure that has one pair of opposite angles that are congruent but not parallel? I thought it, when I was reading this, I thought it said one pair of opposite sides being congruent. If it was one pair of opposite sides, then it could have been an isotrap. If it was one pair of opposite angles, it could have been a kite. So I'm going to have to correct this and repost it. Because really, with what it's talking about, one pair of opposite angles, that's supposed to be a kite, not an isotrap. Here is a proof. We have if both opposite sides are going to be congruent, how do we know it's definitely going to be a parallelogram? Well, we have the opposite sides being congruent given. We have the reflexive property. Therefore, the triangles are congruent by SSS. Therefore, angle 1 and 4 are congruent by CPCTC. And those sides are parallel by converse of AIA. The other angles are going to be congruent by CPCTC, and therefore those sides are going to be parallel by converse of AIA. And next, determine if the following have to be parallelograms. If so, why? Be sure to use the word both when necessary. I added unnecessary information to see if you knew what to ignore. So the first one, the thing that helps you is both opposite angles are congruent. It only has one pair of opposite sides that are congruent, so that's not going to work. The next one says that x and y add to be 180. Since those are supplementary, the left and right have to be parallel. They're also congruent. So it is a parallelogram because one pair of opposite sides is both parallel and congruent. The next one, you have to ignore those opposite angles being congruent because you don't have the other set of opposite angles being congruent, but you do have both pairs of opposite sides being congruent, and that would be your reason. The next one is no. Those aren't opposite sides that are being congruent, and it could be a kite. The next one, you're going to ignore the 8 and the 8 because that's only one pair of opposite sides being congruent. What you're going to look at is that the diagonals are bisecting one another. So yes, diagonals bisect one another. And lastly, that is no, because it's not the same sides that are both parallel and congruent. This could be an isotrap. All right, hopefully that made sense. You guys have 6 different ways that you can prove that a figure is going to be a parallelogram. Do not forget the word both. The word both is very important. Thanks for watching.